Hey everyone, and welcome back to Noel's Marine. Today we're going deep, literally right down into the engine room of a large ocean-going vessel. We're going to explore what is absolutely one of its most critical pieces of auxiliary machinery. I'm talking about the centrifugal purifier.
Now, if you've ever looked around a ship's engine room, you've probably wondered, what exactly is that spinning machine doing? And more importantly, why does the massive main engine depend on it so heavily? Well, let's break it all down, clearly and technically.
Section 1. Basic concept.
So, a centrifugal purifier, which you might also hear called a centrifugal separator, is essentially a rotating machine used aboard ships. Its main job? To clean up the fuel oil and the lubricating oil before they ever reach the main or auxiliary engines. It's almost like a bouncer for your engine, keeping all the bad stuff out.
Its primary function is to remove two main types of contaminants. First, we have entrained water. This is particularly seawater or condensate that kind of just mixes with the oil during storage or transfer. And second, solid particulates. We're talking about things like combustion residues, tiny metallic wear particles, catalytic fines, carbon deposits, and, just general sludge.
Now, the operating principle here is centrifugal force, that radially outward inertial force experienced by a rotating mass. It actually comes down to Stokes' law, which tells us that the rate of separation between two phases is directly proportional to the square of the angular velocity and the difference in density between those phases. So in practical, everyday terms, when the purifier bowl spins at incredibly high speeds, the denser phases are forced toward the outer radius, while the less dense phases just hang out near the central axis.
Section 2. Working principle, step by step. Let's actually walk through the working sequence of a disc-type centrifugal purifier. This is the standard configuration you're going to find on most commercial vessels today.
Okay, so here's how the sequence goes. First up, the feed inlet. Contaminated oil enters through the feed pipe and is directed right into the rotating bowl via the distributor. Then, high-speed rotation. The bowl, along with a stack of conical discs inside, rotates super fast, typically between 6,000 to 9,000 RPM, depending on your exact model. Next is phase separation across that disc stack. These conical discs actually increase the effective settling area and reduce the settling distance between phases, which dramatically improves the separation efficiency. Sludge and solid particles, being the densest, are literally thrown to the outermost edge of the bowl and collect on the wall. Water, which is denser than the oil, forms a ring in an intermediate radius. Its exact position is carefully controlled by the gravity disk, sometimes called the interface disk. Clean oil, being the lightest phase, concentrates right at the center of the bowl and is continuously discharged through the oil outlet. Now, about that gravity disk sizing, this is absolutely crucial. The gravity disk has to be correctly sized based on the specific gravity of the oil you're processing. If it's wrong, you'll even get oil carrying over into the water outlet or water carrying over into the clean oil. Neither of those is acceptable. Finally, sludge discharge. In the older, manual discharge purifiers, you actually had to open the bowl periodically to remove the sludge by hand. But in modern self-cleaning ones, a hydraulic mechanism triggers an automatic sludge ejection at timed intervals or when it detects high back pressure, all without even stopping the machine. Pretty brilliant, right?
Just a quick note here. The machine can actually operate in two different modes. First is purifier mode, which is used for oil with significant water content, and this utilizes that gravity disk we just talked about. Then there's clarifier mode, used when you only need to remove solids. In this mode, the water outlet is completely blanked off with a closing disk. Generally, fuel oil is run in purifier mode, while lube oil might run in either, depending on how contaminated it is.
Section 3. Easy analogy. To really visualize this whole process, just think of a salad spinner, or better yet, a centrifuge in a laboratory. When you spin a tube containing a liquid mixture at high speed, the denser components settle outward and downward, while the lighter liquid stays right near the axis. That is exactly the principle at work inside a purifier bowl.
So, the simple rule to remember here is this. Dense phases go out. Light phases stay in.
Let's look at the numbers. On a ship, fuel oil typically has a specific gravity somewhere between 0.85 and 0.99. Water sits right at 1.0. Sludge and those nasty catalytic fines can be significantly denser, sometimes coming in above 1.1. This exact density difference is what actually drives the separation inside the bowl.
Section 4. Application on board ship.
On a commercial vessel, these purifiers aren't just in one place. They're deployed across multiple systems. We're talking heavy fuel oil, or HFO purification. Then there's marine diesel oil and marine gas oil clarification. Plus, you have your lubricating oil purification and, of course, the diesel generator lube oil.
For heavy fuel oil, the purification temperature is usually kept hot, typically around 95 to 98 degrees Celsius. This maximizes the reduction in viscosity, which significantly improves the separation of water and solids. But you absolutely avoid going over 100 degrees Celsius because you do not want the water to boil. That would completely disrupt the water seal and ruin the separation process. For your lighter distillate fuels, like MDO and MGO, they're typically processed in clarifier mode just to get rid of catalyst fines and sediment. As for lubricating oil, the main engine, auxiliary engines, and turbocharger lube oil systems each have their own dedicated purifiers. They continuously clean the crankcase oil to strip out acidic water, blow-by products, and metal particles. And lastly, auxiliary purifiers are provided for the diesel generator sets, which is super important for long voyages where you really want to minimize oil changes.
Why does all this matter? Well, without effective purification, catalytic fines, those microscopic aluminum and silica particles left over from the oil refining process, can cause severe abrasive wear to your fuel pump plungers, injector needles, and piston ring grooves. Because of this, the purifier isn't just some nice-to-have convenience. It is literally a primary engine protection system.
Section 5. Technical one-line definition. Let's wrap this up with a precise technical summary.
A marine centrifugal purifier is a high-speed, disc-type separator that continuously removes water and solid contaminants from fuel and lubricating oils. It does this by exploiting the density difference between phases under centrifugal acceleration, in accordance with Stokes' law, thereby protecting vital engine components from wear, corrosion, and dangerous deposits.
And that is the centrifugal purifier for you. A compact, furiously spinning machine that quietly protects millions of dollars worth of marine diesel engines running around the clock deep down in the engine room. If you found this explainer useful, go ahead and give it a like, share it with your fellow engineers or maritime cadets, and subscribe to Knowles Marine for more deep dives into ship machinery. Hit that bell icon so you never miss an upload, and we'll see you in the next one.